The metallic silhouette of the Orion capsule glides 6,550 kilometers above the craters of the far side. Why did Artemis II bypass the Moon without entering orbit? The answer unveils a calculated risk that redefined human navigation in deep space. On April 6, 2026, the 4 astronauts crossed our satellite's shadow line. Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen watched the gray regolith through the small hatch window. The silence of the Moon's dark side marked the point of greatest isolation in recent human history. Radio communications with Earth were severed by the satellite's rocky mass. It was the first crewed encounter with the lunar vicinity in over half a century. Global anticipation was for a prolonged stay, a moment of stationary contemplation above the tranquility sea. But the telemetry instruments on the main panel told a different story. Gravity pulled the craft steadily. Speed increased with each passing second, and the main thrusters remained in absolute silence. There was no insertion burn, no orbital capture. The spacecraft merely followed the satellite's curved contour, using the Moon's own mass as an invisible slingshot to return home. The green trace on the control monitors displayed the mass of the Moon as the primary engine for that April week's maneuver. 5 days prior, on April 1, 2026, the 4 SLS rocket engines illuminated the pad at Kennedy Space Center. The shock waves swept across the Florida swamps. The end 53 years hiatus since the Apollo 17 crew left the lunar surface in December 1972. The Artemis II mission marked the return of human presence beyond low Earth orbit, but the flight plan drafted on the consoles in Houston was fundamentally different from the one that inaugurated crewed lunar exploration. On Christmas 1968, the Apollo 8 crew executed an aggressive braking maneuver. Frank Borman, Jim Lovelace, and Bill Anders fired the service engine for 4 long minutes as they passed behind the Moon. That burn reduced the craft's speed, allowing lunar gravity to definitively capture it. They completed 10 circular orbits over 20 hours. They photographed Earthrise over the horizon, mapped landing sites, and needed to fire the engine again with mathematical precision to escape orbit and return. Artemis II did not replicate that choreography of braking and acceleration. Orion's navigation panel was programmed for a single flyby, a swift, continuous, non-stop passage. The decision wasn't a technical limitation of the new space vehicle. It was a deliberate choice of orbital engineering designed to test the limits of survival in the vacuum. The spacesuits and the craft's vital systems would face a far more rigorous test than a simple orbital insertion. Entering lunar orbit demands a maneuver known as lunar orbit insertion. It's a moment of extreme mechanical tension. The spacecraft travels thousands of kilometers per hour from Earth and must fire its thrusters to brake at the exact moment at the precise altitude. If the engine fails to ignite, the craft passes straight into deep space. If the engine burns too long, the craft loses excessive speed and collides with the surface. And once stabilized in orbit, the crew depends entirely on a second perfect burn days later to return to Earth. The architecture of Artemis II completely removed this failure point. Instead of braking and latching to lunar gravity, the craft was injected into a free return trajectory. It's an elegant mathematical trace that draws the shape of a gigantic figure 8 in space. The spacecraft crosses the translunar void, bypasses the satellite's far side, and allows gravitational force to naturally curve its route back to Earth. Once the rocket's upper stage pushes the capsule in the correct direction while still near our planet, Orion's main engine doesn't need to be fired at any point to ensure its return. Celestial physics itself guarantees the unconditional return ticket. If the propulsion system suffered a total failure during the outbound journey, the crew wouldn't be stranded in space. Inertia would bring them back. But this mechanical safety created a scenario of unprecedented physical distancing. But the telemetry lights in the control center revealed the true nature of the mission in this scenario of isolation. If technology had advanced 5 decades, what made lunar orbit an unnecessary risk for the timeline? The answer lies in the very structure of the vehicle. The Orion capsule didn't travel to explore the geology of craters or map resources at the South Pole. It traveled to prove it could keep 4 human beings alive and functional in deep space for 10 interrupted days. The free return trajectory isn't just a safe path, it's a long one. By not engaging the brakes to enter orbit, Orion maintained its massive inertia and was flung far beyond the Moon's far side. The craft continued ascending into dark space, moving away from the satellite and Earth simultaneously. The monitors registered the distance increasing without pause: 384,000 kilometers, 390,000 kilometers, until the numbers on the console reached the mark of 400,171 kilometers from Earth. It was a new absolute record in exploration history. The Artemis II crew went farther than any other human being had ever been, surpassing the historic mark set by Apollo 13. The view through the small window was of a tiny Earth, too distant to offer any immediate rescue. The recycled oxygen and carbon dioxide filtration operated at the very limits of their capacities. At this point of maximum distancing, at the apex of the gravitational curve, survival depended solely on the integrity of the pressurized hull and the precision of the heat shield awaiting them on re-entry. The 5-meter diameter heat shield at the capsule's base dictated the entire final geometry of the return flight. The agency's primary objective wasn't to put boots on the regolith on this specific mission. That moment is reserved for the future Artemis III. The central goal now was to subject the spacecraft to absolute thermal stress. When a capsule returns from low Earth orbit, like vehicles from the International Space Station, it hits the upper layers of the atmosphere at about 27,000 kilometers per hour. It's an intense but well-documented re-entry. But when returning from deep space, free falling from lunar orbital distance, Earth's gravity accelerates the craft for hundreds of thousands of uninterrupted kilometers. The kinetic energy accumulated in that descent is immense. Orion would hit the Earth's upper atmosphere at an astonishing 39,000 kilometers per hour. The friction of air molecules against the craft's base would generate temperatures exceeding 2,700 degrees Celsius, heat equivalent to about half the temperature on the Sun's surface. To scientifically validate whether the new ablative material would withstand this extreme plasma heat without melting the cabin, the craft needed the exact speed of a real lunar return. A low Earth orbit test would never simulate these conditions. The free return flyby delivered exactly the necessary speed and angle of attack. The Moon acted merely as a colossal gravitational mirror, reflecting the spacecraft back to the mission's true testing laboratory, the wall of Earth's atmosphere. The thermal data collected during this passage will define the safety of future generations of space explorers. The plasma trail tearing through the sky and the ocean impact validated every mathematical decision of the planning. Artemis II bypassed the Moon without orbiting it because the mission never had the satellite as its final destination. The target was the vehicle itself. The free return trajectory ensured crew safety against propulsion failures, while using lunar gravity to stretch the journey to its maximum limits of distance and speed. By foregoing a stationary orbit, the mission proved that Orion can withstand the isolation of deep space and bring its occupants through the extreme heat of re-entry. The splashdown in the waters of the Pacific Ocean in the afternoon of April 10th concluded 10 days of absolute confinement with surgical precision. In our next episode, we'll investigate Orion, the capsule, how it kept 4 people alive in 10 days of the vacuum. The salty water cooling the darkened metal closes a chapter on the surface, while the capsule's interior still holds the memory of that long silence.